welcome back to Max lecture series. So in this series we are obtaining solution for higher order differential equation. Of course we will be focusing on only complementary function, but as I told you, for higher order differential equation we will be having two solutions. One is complementary function and another one is particular integration. But this particular integration will be 0 when the right hand side will become 0. We know that. See there, if you observe, for the given differential equation also right hand side is 0. If the right hand side is 0, then particular integration will be 0. We will be having only complementary function. Now if you observe the numerator, we will have x here. Numerator variable will be dependent variable. Denominator variable will be independent variable. Then how will you write down the solution? Dependent variable is depending on independent variable. So x of y is our solution. Don't forget. Be very cautious with your solutions. Okay sir. Now step number 1. D square y by dy square will be replaced by capital D square into x plus 4 times of d by dx will be replaced by capital D plus x plus 8 times of x. Okay sir. After that, from here if you observe, we know the common dependent variable is x. Take it out, then you can observe there will one polynomial equation. Now, how to obtain the solution for the polynomial equation? As I told you, if you are unable to find the values, roots of this polynomial equation, then directly use the formula minus b plus or minus b square minus 4ac by 2a, whereas b is the coefficient of second term, a is the coefficient of first term, c is the constant. Now, whereas the value of a equal to 1, b equal to 4, c equal to 8. Substitute all the values, b equal to 4, here b square minus 4, a equal to 1, c equal to 8, divided by 2, a equal to 1. By solving it, we will obtain the solution minus 2 plus or minus j2. Wow! See there, our root is a complex root. When the root is complex, how will you write down the complementary function? In the last lecture itself, we saw whenever our root is a complementary, that is a complex. If our root is a complex, like it will be the combination of alpha plus j times of beta, then the solution can be written as e power alpha times of beta alpha x into, in bracket we have to write arbitrary constant a, then b, then put addition, then we should multiply it by cos beta x, second term will be multiplied by sin beta x, where alpha indicates the real part of the root, beta indicates the imaginary part of the roots. In the same fashion, see there, first I wrote, why I wrote x of y? Because here y is independent variable, x is dependent variable. So you have to write down, see there, here I also did the mistake. Let me write down. Step number 1, what we have to do? Write down e power alpha y independent variable, and then in bracket arbitrary constant a plus arbitrary constant b, then multiplied by cos beta y sin beta y independent variable. Then what will be the answer? From here we can say alpha, we have to replace alpha by, see there, this can be written as alpha plus or minus j times of beta. So if I am comparing it, alpha equal to minus 2, beta equal to 2. Replace it. So the solution is going to be e power minus 2 times of y in bracket a times of cos, beta will be replaced by 2 plus b, beta will be replaced by 2 sin 2y. That's all. This is going to be our complete solution for the given equation. That is how we are obtaining complementary function. That's all. Sir, suppose if the complementary roots are repeated, we know always they will be a pair. You can observe complex roots are always pair. Same value will be repeated with the plus or minus signature. Okay sir, suppose if the given differential equation will be in fourth order, then what shall I do? See here in complementary roots, you can't expect third order at all, because always complementary roots will be giving us pair roots, pair values. So 2 will exist, then 4 roots will come, 6, 8 like that. So when fourth order will be repeated, like same roots will be existing 2 times. If 2 pairs are repeating same values, then what you have to do is same fashion. Write down e power alpha, see there, here also I did the mistake. Here what is our independent variable? The independent variable is y. Be conscious with that. So it should be y. Okay, sir. If the roots are, we know when the roots are complex, then it can be written as e power alpha y, arbitrary constant a cos beta y plus arbitrary constant b sin beta y. But since the roots are repeated, if the roots are repeated, then add one more arbitrary constant. Then we know, do you remember when the real roots are repeated, then I asked you to multiply it by independent variable. Minimum order will be started with y power 0, then y power 1, y power 2, y power 3, etc. Here the independent variable is y. Start with the minimum order. A will be multiplied by y power 0 plus add one more constant multiplied by y power 1. Similarly, b will be added with one more arbitrary constant d multiplied by y power 1. That is the only change. Here you can use any arbitrary constant. It is not necessary that we have to use a, c, b, d. Any variable you can use. But just observe the changes. Initially we have only a into y power 0. Independent variable always will be multiplied here, but the thing is power is 0 when we have only one arbitrary constant. So power 0 means that value will become 1. We are not considering it. But when the roots are getting repeated, then we have to increase the arbitrary constant. Now add one more arbitrary constant multiplied by y power 1. Suppose if you are having 6th order, then what will be the solution? See there, 6th order e power alpha x, one arbitrary constant into cos beta x plus b into sin beta x. This is normal. When we have two repeated order, then what will happen? A plus c into y power 1 will come plus d into y power 1 will come. If we have three repeated pairs, three repeated roots, like one more pair with the existing same values alpha plus or minus j beta, then one more arbitrary constant, this time y power 2 will come, y power 0, y power 1, y power 2. Again y power 0, y power 1, y power 2. Y power 0 value is 1, I am not considering it here, that is why I am not putting it here. With the b we have 1. After that d into y plus f into y square. See, that is how we are writing the complete complementary function for imaginary roots. So only we have two type of roots, either we may have real roots or you may have complementary roots, complex roots. Now we understood if real roots will become how to write the real roots. If it is distinct, then we understood that if the roots are distinct, then how to write down the roots. I told you, we have been observed in the first case. When the roots are real and different. If the roots are real and repeated, then we know how to write down the solution. Then we saw if the root is complex, okay, if the root is complex, then how to write down the solution. We have been observed. If the root is complex only, but in first case we saw purely imaginary, second case we saw both real and imaginary part is not equal to 0. Finally, I just given the brief introduction. If the roots are complex roots, it is having both real and imaginary part. Suppose if it is repeated more than one times, if you are having fourth order at all, then how to write down the solution. See, just you can have a brief look into this, that's all, because in the examination maximum focus will be on second order. Sometimes there will be a chances of getting fourth order. They may give you the clues to identify the fourth order roots directly. You can expect direct solution. You are supposed to write down the final answer only directly. How to write down the final step, complementary function for fourth order, sixth order. In that case, you have to write down the solution. Okay, this is all for this lecture. In the next lecture, we will be coming up with a few more models. Thank you all.